Picture a device about the size of a thick hardcover book. No screen, no keyboard, no user interface of any kind. It runs the same four-step program every 10 milliseconds, 24 hours a day, for 20 to 30 years without interruption. By the end of this lecture, you will be able to explain what a PLC is, describe how it operates, and distinguish it from a general-purpose computer. A programmable logic controller is an industrial computer with one purpose: reading sensor data and sending commands to actuators. Actuators are the physical devices, such as motors, valves, and pumps, that carry out those commands. No web browsing, no multitasking, no background processes. Just one program in one deterministic loop running continuously. The defining characteristic is deterministic execution. The PLC responds within a guaranteed time window every single cycle. The PLC operates in a continuous loop with four steps. First, input scan. Read all sensor states into memory. Second, program execution. Run control logic, the set of instructions that defines what the PLC does against that snapshot. Third, output update. Write all results to physical outputs at exactly the same instant. That simultaneous update matters. Every output changes from the same input snapshot, keeping the process consistent. Fourth, housekeeping, communications and diagnostics. Scan cycles typically range from 1 to 50 milliseconds. At 10 milliseconds, the PLC completes 100 cycles per second. Before PLCs, factories controlled machines using relay circuits, banks of electromechanical switches wired together in panels. PLCs replaced those panels in the 1970s. Ladder logic was designed to look exactly like the relay diagrams electricians already knew. Two vertical power rails, horizontal rungs connecting them, conditions on the left, outputs on the right. A technician with no programming background could read it immediately. That was the design goal. Decades later, ladder logic still holds approximately 46% of the PLC programming market. I/O stands for input-output, one connection point where the PLC reads a sensor or commands an actuator. Micro PLCs have 8 to 20 I/O points and handle simple machines. Modular units use a chassis, a backplane holding separate processor and I/O cards. They scale to hundreds of connection points for entire production lines. Siemens leads in Europe with the S7 series. Rockwell Automation dominates North America with Allen Bradley. Schneider Electric Modicon is strong in utilities and infrastructure. Automotive assembly lines, pharmaceutical batch reactors, food and beverage production, water treatment plants, power substations, airport baggage systems. Anywhere a machine reads a sensor and must respond in real time, a PLC is almost certainly doing the work. The criteria are simple: reliable, repeatable, real-time control. That is what PLCs do and have done for 50 years. That device you pictured at the start is the PLC. No screen, no keyboard, just the same four-step loop running for decades. It is the brain connecting digital instructions from operators and engineers to the physical actuators doing the work. Every other component you study in this section connects to it, depends on it, or communicates through it. This lecture is part of the free Introduction to Industrial Control Systems course. 25 lectures, no cost, link in the description.